We've talked about intakes, and now I want to talk to you a bit about shooters, which is another element that you will need to use in the first games. Most games have a higher and lower target for where you want something to end up. So look into this and the restrictions that you're given with the game rules. You also want to look into what type of object you are trying to manipulate. So very similar to the intakes, your shooters will have to manipulate different kinds of materials like different plastics, maybe wood, metals, who knows. They could throw anything at you. And again, you want to build this and iron out all the errors that you see. So I explained different ways to troubleshoot in the intakes videos. Depending on what type of system you have, there are more and less effective ways to troubleshoot. Again, the rubber wheels are used in a shooter. So this can be constructed by basically having two arms and then the wheels attached to the end. There are obviously many ways to configure this, but basically these two wheels here will spin to intake the ball, and then they can also spin in another direction to shoot it out. And this is a common one that we see, that it's very reliable, which is why we see it commonly, and it's quite simple. It's easy to change the angles and how fast you want the wheels to be spinning. So it's very versatile for different objects and different heights. We've also seen that, actually we've done this on one of our robots, where we've had it on an arm that can move up and down. We used pneumatics for it, but you can use a motor if you like. And that way we get to shoot to the different levels. So when it was down, we could shoot to the lower hole, and then when it was up, the other targets. So that's one way you can make it more versatile and design it around the situation that you're faced with. So another one is a claw similar to the other claw in the intakes, with 2 or more fingers, and it's good with precision, as I said before. So it has the capability to move an item to a specific location, and it can have several points of rotation, which allows it to again, move it to a precise place. And as I said before, there are many different styles of claws you can use, different materials, different axes of rotation. Now another intake that we see sometimes is a belt system, and the goal is to smoothly move an object. Some people use surgical tubing for this, and they might even have two different sections and it'll go in between them. Here's a picture, and we have seen it work quite effectively, but us personally, we did this on one of our robots and it was not fruitful and brought a lot of frustration. One thing you have to look at, depending on what material you're using, is tensioning your belt. So we had the issue of the belt untensioning a lot, so it wouldn't actually move the cubes where we needed them to go. So we have seen it work. We have also seen it fail utterly. I'll attach a video of a few good belt systems below this video. I also want to briefly touch on the climbers that you can use. So every competition will have a climbing aspect to it. Generally it's some kind of a post or a platform that you have to hoist yourself up to. So there are many different ways to, again, make this subsystem. It's totally up to you, but some of the common ones we see, many teams will have something that extends upwards, and then a hook that falls onto the post, and then it pulls itself up using the motor in the opposite direction. That we've seen this to work. We've also had difficulties with this type of system. Because you are using a hook, it might need you to be precise. Another one that we see is having something extend from the bottom of the robot is also something that we commonly see. But there are many ways to change the elevation of your robot, which is essentially what you need to do. So another thing we see is a scissor lift, which can be more risky because if something goes wrong, it can easily collapse, and that may be the end of your robot. You may also be able to use a pulley system, taking advantage of the mechanical advantage. So for climbing, there are many different ways to achieve it, and it's often one of the more difficult parts of the robotics competition. We always hold our breath when it comes to the last minutes of the competition, and the robots are all going for climbing. If you're prioritizing this in your design, then dedicate your time to it. But sometimes robots will not do the climb, and that's okay too. You just have to make sure that your robot is very efficient at other parts. So for shooters and climbing systems, you want to look at what other teams have done, how they've succeeded, and maybe mirror your project off of that. And you can also come up with new designs. But I'm going to link some videos down below of some systems of shooters and intakes that have been shown to work very well. And you can look at the principles that these use to design your own